Okay, so today's lesson is on isolating variables and modeling with formulas. So, let me just get this. A formula describes the algebraic relationship between two or more variables. Scientists are continuously creating formulas to solve problems. Using the rules of operations, formulas can be arranged to solve for different variables. This is useful when we want to substitute a value into the formula. So here's an example. The equation of a line can be written in the form y equals mx plus b. Okay? But we can arrange the equation to solve for b if we want. Okay? And we can also arrange the equation to solve for m. So let's do the first one. I'm going to start with writing the original equation, y equals mx plus b. Now, right now, we want to solve, isolate b, which means you want to solve for it. So we're going to move everything that is not b on to the other side. So, this mx, if you're to get rid of it, right now it's a positive mx. So when you bring it over, it becomes a negative mx. So I'm going to have, wrong one, y minus mx equals b. Okay, so that one was pretty straightforward. Now we'll do one that's a little bit more complicated. This next one, we want to arrange the equation to solve for m. So we're going to solve for this little guy. So I'll start by rewriting the equation y equals mx plus b. Okay, and the first thing that we can do is we can move this b over. So positive b turns into a negative b. So I'm going to have y minus b equals mx. Okay, now we still need to isolate m. So right now it's multiplied by x. So the opposite of multiply is divide. So we're going to divide by x. And if you do it on one side, you have to do it to the other side. So your final answer is y minus b divided by x equals m. And there's your final answer there. So next question. It says the formula to calculate the circumference of a circle is c equals 2 pi r. So now we're going to rearrange the formula to solve for r. So this little guy. Okay? So I'll start by rewriting c equals 2 pi r. Okay? So because right now r is multiplied by 2 pi, we have to do the opposite function, would be divide by 2 pi. And if you do it on one side, you have to do it to the other side. Okay, so now we are left with circumference divided by 2 pi equals r. There's your final answer. So remember, if I'm ever going too fast, just pause and rewind as many times as you need. Next, the formula to calculate the perimeter of a rectangle is perimeter equals 2 times, in brackets, length plus width. Now we want to arrange the formula to solve for L. So I'm going to rewrite this first. P equals 2 times L plus W. Okay, so first things first is this whole thing is multiplied by 2. So we need to get rid of this 2. So the only way to get rid of 2 is to divide by 2. So we can divide by 2 on one side, but you have to keep it equal, so we have to divide by 2 on the other side. Okay? So now we are left with P over 2 equals length plus width. Now because we want to solve for L, so we need to get rid of W. So because it's a positive W here, when you move it here, it becomes a negative W. So it's going to be P minus W over 2 equals L. And then that's your final answer. Okay, I had a little malfunction, but I'm back. Okay, so next question. It says the formula for kinetic energy is K equals 1/2 mv squared. So we're going to arrange the formula now to solve for m. So this one right here. So I'm going to start by rewriting the formula. K equals 1/2 times m times v squared. Okay. So we'll do one step at a time. So right now, because it is multiplied by 1 and then divided by 2, we're going to multiply both sides by 2. Okay? So that means we're going to multiply this side by 2. And we can multiply this side by 2. So I'm going to be left with 2k equals these to multiply by 2. Oops. Multiply by 2 and divide by 2. Multiply by 2, divide by 2. That equals 1. So we're left with just mv squared. So now we want to solve for m. So we have to divide by v squared. And if you do it on one side, you have to do it to the other side. So now you're left with 2k divided by v squared equals m. Next one, they want us to arrange the formula to solve for v. So this one's going to be a little bit trickier, but we got this. Okay, so first things first, I'm going to write the equation k equals 1/2 times m times v squared. So first thing we're going to do is, like the other one, we have to get rid of this fraction. So because it's divided by 2, we have to multiply 2. And so you got to do it on both sides. So we're going to have 2k equals mv squared. And that's same reasons we did over here. Okay? Now, we want to get v all by itself. So now we have to divide by m because it's multiplied by m. So if you do it on one side, you have to do it to the other side. So we're left with 2k divided by m equals v squared. Now this one, little tricky. So because we have the squared, the opposite of square is square root. So we need to square root both sides. So now I'm going to take the square root. And if I do it on one side, I do it to the other side. So we're left with the square root of 2k divided by m. And then here, square root and squared sign cancel each other, so we're left with v. And this is your final answer. Next. Okay, so now we're on some application questions. It says, as you increase altitude, the air temperature drops at a rate of 1 degree Celsius for every increase of 150 meters. Scientists have determined that temperature changes can be calculated according to this formula. Capital T equals little t subtract h divided by 150. So this is the key part. Capital T is the air temperature at an altitude. So that's up in the sky where the clouds are. Okay. Let's see. Air temperature at an altitude. So altitude is h. So that's how high we are. And little t is the ground temperature. Okay, so off to the side, I'm just going to write some of these down as a reminder, okay? So we have capital T, that is air temp, and that's in the clouds, okay? Then we have little t, which is the ground temperature, okay? So you have your trees, and we're talking about the ground. Okay, and H stands for the height. So now we can go ahead and solve these. So I'm going to rewrite the formula. Capital T equals little t subtract h over 150. So this question right here, it asks us to calculate the temperature at a height of 750. So height now is going to be, sorry, not 750, 7,500 meters. Okay. We want to know when the air temperature at the ground is 28. So ground temperature, let's take out this. Ground temperature is 28 degrees. Okay, so we're solving for capital T. So capital T equals little t is 28. Subtract H is 7,500 and divide it by 150. So capital T equals, we still have our 28. We can do it in our calculator right here. 7,500 divided by 150. And you get 50 as your answer. So it's 28 minus 50. And then that means our air temperature up in the sky would be 28 minus 50. And that gives us minus 22 degrees Celsius. Okay, so because it's a word problem, you'd have a therefore sentence. Okay, so it's hard for me to write on here, but you would write therefore the air temperature would be minus 22 degrees Celsius. Okay, next question. It says, suppose we need to calculate, one sec. So suppose we need to calculate the air temperature at ground level, T, when we know the altitude, H, and the air temperature at the altitude, T, capital T. Okay, so isolating T in the original formula will make the substitutions and calculations easier. So, let's just write, where's my pen? Oh, why isn't this working? Okay, oops, there we go. Okay, so just remember, capital T is the air temp, little t is ground temp, and H is, oh actually it's a little h, sorry. Little h is the height, altitude. Okay, so we're going to rearrange to solve for little t, so isolating t in the original. So this is what we're going to do. We're going to take this negative h divided by 150 and add it onto this side. So we're going to have t plus h over 150 equals little t. So this is our new formula. So if you wanted, you could also write it like this. Some people like to have it like t equals, and just writing it backwards, big T plus h divided by 150. Okay, so let's do this now to answer the question on the other side. Okay, so I copied the formula from the other side over here. So we have little t equals capital T plus h over 150. And here I just filled in what we know. So the temperature in the sky is 5 degrees Celsius. We don't know the ground temperature because it says use the formula to calculate the temperature at the ground level when the altitude is 2,500 meters. So the height for the altitude is 2,500 meters. So now we're just going to fill everything in. So little t equals, our capital T is a 5 plus the height in altitude is 2,500 divided by 150. And then when you figure this out, it's 5 plus, well, 2,500 divided by 150 is 16.67. And when you add those two together, you will get 21.67, but we round it up to 22 degrees Celsius. And that's the end of that question.